Hi, my name is Taesoo Kim, and today I'm going to tell you about a practical and effective sandboxing mechanism for non-root user. This is joint work with Nickolai Zeldovich at MIT. First of all, why do we need yet another sandbox for desktop application? There are many existing sandbox mechanisms such as chroot, jail, and seatbelt in commodity operating system, or you can use virtual machine to sandbox an application. But unfortunately, all of the existing sandboxing mechanism is either difficult to use, requiring special privileges, or slow in performance. So we decided to design our own sandboxing mechanism such that non-root user can easily benefit from it. Long story short, how our sandboxing mechanism work? For example, when you download a binary from the internet, in order to sandbox that application, you need to run the binary with our tool, Mbox. And during the execution, we intercept network accesses of the sandbox application, and at the end we summarize network activity such as where to connect and how many sockets they create, so that the user can have some sense of how the sandbox application behave. Also, Mbox protect your host file system by overlaying a sandbox layer on top of it, so that all of modification such that sandbox application make will take place in the sandbox layer instead of affecting your host file system. When sandbox application terminate, we ask the user whether to check their content inside the sandbox or copy them back to the host file system if they want. More importantly, we achieve all of those features without acquiring new privileges. Mbox consists of two components, the layer sandbox file system and system core interposition. The layer sandbox file system protect the host file system by overlaying it so that it can confine all of modification made by the sandbox processes. The layer sandbox file system is persistent storage, in fact just a regular directory in the host file system. When the sandbox application terminates, user can have complete control over it, such as checking their content and copy back to the host file system. We implement the layer sandbox file system with system core interposition, so that non-root user can easily benefit from it because most of the commodity operating system provide one for non-root user, mostly for debugging purposes. By interposing on system core, we could enable a variety of applications such as installing packages without root and restricting network accesses of the sandbox application and creating a build and develop environment without custom tool. Let me first motivate you with a variety of applications that we can provide for non-root user. For example, suppose that your server provides very old version of packages and you don't have a root privilege to update it. In order to install the latest version of software, you probably download the source code, visual dependencies, and compile by yourself. Using Mbox, you can install latest version of software with standard package manager, because Mbox can provide a writable sandbox layer on top of the host file system, so that the standard package manager can install the packages to the sandbox layer. After you install the packages, the sandbox layer contains not only the newly installed package files, but also the package databases. So you can install more packages later, or removing them totally detached from your host file system. In order to support standard package manager without any modification, Mbox needed to emulate a fake root environment so that we can support package managers for Ubuntu and Debian and pip for Python. Also, using Mbox, you can run unknown binary safely. For example, when you download a binary from the internet, by running the binary with Mbox, you can protect your host file system, and also you can restrict the network access of it, so that the sandbox application cannot modify your host file system, and at the same time cannot leak any data out of it, so that you can run unknown binary safely. Also, using Mbox, you can checkpoint the file system instantly. For example, when you're editing an Emacs configuration file, what if you make a mistake so that your Emacs configuration file is broken? You probably run vanilla Emacs to fix the bugs in your Emacs configuration file, but using Mbox, you don't have to worry about overriding file or deleting a file in host file system, because all of modification will take place in the sandbox layer. All other instances of Emacs never see your modification. After you verify your new Emacs configuration file is working fine with the in Sandbox, you can commit them back later to the host file system. Using Mbox, you can also create build and development environment without any custom tool. For example, when we compile a project source tree, we often see that the project directory contains the source code and generated object file at the same time. Using Mbox, you can redirect all of generated file to the single directory. By doing so, make clean like operation is particularly simple. You can just remove the output directory. Mbox can also be used for virtual development environment, such as virtual env for Python, by reusing the output directory over and over again. From now on, let me talk about some technical detail that make all of use cases possible. First, I'm going to talk about the layer Sandbox file system and system call interposition, particularly how to use SYCOM BPF. First, Sandbox file system support copy on write. When we run the Sandbox process, the Sandbox file system starts as an empty directory. When the Sandbox process read a file, because this read operation never affects your host file system, we simply allow the Sandbox process to access the file. But when Sandbox process write to the file, because write operation might modify your host file system, in order to protect your host file system, we first copy the file from host file system to the Sandbox layer and make the Sandbox process to access the file in Sandbox file system. Then how does this mechanism work? In fact, the Sandbox file system is a regular directory. In order to make the Sandbox process to access the file in Sandbox layer, we simply rewrite the path argument of open system call by appending the path of Sandbox directory. After we modify a file, or subsequent read and write on that particular file should happen on the Sandbox layer, so we similarly rewrite the path argument of open system call. When Sandbox file system deleted a file, we need to keep track of a list of deleted files because all of subsequent read on that particular file should not happen on the host file system. In those cases, we similarly rewrite the path argument of open system call. One nice property of this mechanism is that we don't have to interpose every single system call in order to provide the writable Sandbox file system. For example, we don't have to interpose and read and write system call because when we're executing open system call, we already rewrite the path argument so that the file descriptor is still pointing to the correct place when we are executing read and write system call. In Mbox, we interpose about 50 number of system call, getting a path as an argument in order to provide a writable Sandbox file system. Now, what are the available mechanisms for system call interposition? The most common technique is to use ptrace. By using ptrace, we need to interpose every single system call in order to provide a writable Sandbox file system. By using SYCOM, we fortunately found a solution called SYCOM BPF, which is recently introduced in Linux 3.5. In fact, the SYCOM is a security mechanism for isolating a process by allowing a certain set of system call. By using SYCOM BPF, user can specify rules for filtering system call using Berkeley package filter. In order to interpose a system call using BPF, Mbox first needed to download the BPF program to the kernel using SYCOM BPF interface. The BPF program contains a list of system call that we need to interpose in order to provide the writable Sandbox file system. After we download the BPF program, Mbox invoke the Sandbox process. Whenever the Sandbox process executes a system call, BPF program runs and decide whether to interpose or not. For example, when Sandbox process execute open system call, the BPF program runs and generate a SYCOM event, so the Mbox waiting for a signal of the child, wake up, and examine the memory of the Sandbox process, rewrite the path argument if necessary. But unfortunately, in order to implement this mechanism correctly, there are many problems to consider, such as how to avoid time of checked time of use problem and how to avoid replicating operating system. But if you're interested in our solution on those problems, please check the paper. We implement this idea as a prototype for Linux. By extending strace, we provide distribution packages for Ubuntu and Arch. We evaluate our implementation by asking two different questions. How much overhead does Mbox exhibit? And how much faster is a SYCOM BPF compared to ptrace? In order to answer those questions, we construct a benchmark, and we run each benchmark in 3 configurations. Without Sandbox, Sandbox with ptrace, and Sandbox with SYCOM BPF as a means for interposing a system call. First, Mbox imposes modest end-to-end performance overhead. In our benchmark, Mbox imposed 0.1% to 20% depending on the workload. Particularly in a computation-heavy workload, Mbox exhibit negligible performance overhead. For example, Octave benchmark that calculate the matrix multiplication, Mbox imposed 0.1% because it spent most of its execution time in user space without generating any system call. Secondly, CCOM-BPF reduced the interposition overhead. Unlike ptrace mechanism that we need to interpose every single system call, using CCOM-BPF, we could interpose a certain set of system call. Compared to the ptrace mechanism, CCOM-BPF could reduce overhead up to 25% in our benchmark. Lastly, CCOM-BPF has better concurrency than ptrace. When we're compiling the Linux kernel with 4-petal job, using CCOM-BPF, performance can be improved about 65% compared to the ptrace. Using CCOM-BPF, we could avoid unnecessary serialization of system calls so that multiple processes can execute simultaneously. There are 3 large bodies of later work: the layer file system call interposition, and namespace. In terms of layer file system, we follow the unification rules and copy and write scheme of UnionFS, but in our work, we implement the layer file system by interposing a system call so that non-root user can easily benefit from it. OSES-like project using system call interposition to enforce security policies, and they studied a common pitfalls of using it. But in our work, we summarize our experience of using rather recently introduced in CCOM-BPF. You can compare Mbox to the private namespace of Plan 9, but in our work, we implement the private namespace by interposing a system call so that we could enable a variety of application using a variety of application for non-root user. In summary, we introduced Mbox, a lightweight sandbox mechanism that provides layer sandbox file system, revision control system like sandbox usage model. We implement those features interposing a system call with efficient CCOM-BPF so that we could enable a variety of applications for non-root users. I think this is the end of my talk. If you have any questions.
I'm Oyama from UEC Tokyo. I am wondering how Mbox emulates the behavior of the get-to-dents system call.
Which system call? Sorry.
Get-to-dents, get-to-directory entries.
Oh, directory entry? Yeah, that is only like fake system call that we need to emulate everything in the user space. That's why we're talking about how to avoid replicating operating system state. So if you're interested, you can check the paper. For more detail, like just emulate exact same thing in the user space.
So you create a list of fake directory entries?
Yes, exactly. Only that get the end towards those dirty system calls.
Thanks.
Other than that, just you can rewrite the path is enough for most of the system code that we interpose, about 15 number of system code.
Hi, this is Richie from VMware. Many years ago, there are several, similar approaches many years ago. And for example, there's Alcatraz. So I think the technique seems very, very similar, except probably they only use ptrace, not the BPF, which is not available at that time. So I'm wondering whether you have a look at that kind of papers and what's the difference in your approach. Thanks.
Yeah, I'm probably young enough to don't know about the project. Just
quick question. So
yeah,
earlier you mentioned about downloading patches and being able to run them in the sandbox part of the file system. So what happens if the patches make privileged calls, like trying to pin itself on a core or something like that?
We rely on the privilege of user. So if you run a process, the process run on behalf of your user ID, we definitely rely on the user ID protection scheme in the operating system. In those cases, you should, like for example, sudo command, you should put your password in order to run your application though, using Mbox.
Do you trace those system calls as well? Or?
If you specify, for example, common package manager, they check your user ID before actually installing something. It just stop after, like, if not return root user ID. In those cases, if you specify like fake root environment option, we definitely do emulate those kind of system calls.
What happens when, can you have two Mbox sessions running concurrently? When there's the virtual file system that you create, what happens if they both modify the same file, for instance?
If they modify the same file, they never see their own modification each other, because the Sandbox file system is a regular directory. They create like temp/PID, for example.
Okay.
So each process is run independently. Also, you can download the BPF program. Just BPF program is just stick to the socket, your PID, so it doesn't matter.
Okay, so it's forked by the PID of the process.
Yes.
Okay.
More interesting question is probably one single process running inside the Sandbox, the other process modifying your file without, like, outside of your Sandbox. They probably will say this is conflict.
Okay.
In those cases, there are a couple of solutions that we were talking about in the paper, if you're interested in.